Alright, so in this video, what we're going to be working on is creating the ItemBase class. Just a couple of things that I've done before I was recording is I reorganized the project folder. When you add stuff from the marketplace, it always puts it right into the content folder. And as you go along and continue to expand your project, that can get super messy because if you have all your specific game content mixed in, it's just very disorganized. And so all the folders I've been making, such as the ItemData, I made a blueprints folder to hold my character and all that stuff. I put it into a new folder here with the name of the project. That way, when we add assets and stuff, they're all on the same level, but you keep your specific game files separate. And so with that, you can see here I've added the Infinity Blade Assets pack. So I had forgotten about this, but this is a perfect pack to add for what we're going to be doing, working with inventory. It's free, obviously, because it's part of like the permanently free stuff. And if you go in here and look at it, if we go into meshes, it's got all kind of stuff that'll be great for inventory, prototyping. We've got these little bottles. We've got some, let's see, I don't know, skulls. Like, there's plenty of little things here you could use. Oh, yeah, potions, definitely. What else? Little treasure bags, all this kind of stuff that would be probably pretty easy to find icons of. And then we can, use these as the meshes so to interact with in the world and add to the inventory. So this is a perfect one to add if you haven't found something already or don't already own something that you want to use. I'm going to go with this. So now let's get to working on the ItemBase class. So we made our data table. And I really haven't added much to it since the last video because it's not really necessary quite yet. So it'll be more useful when we can kind of have a representation of it and a place to store it and all that. So I've just kind of left the data table as is for now. I'm going to go to C++ classes here and go to new class. And now the item base class is going to be a pure data class. It doesn't have a visual representation. That's going to be called the pickup class, which is going to be an actor. We'll worry about that one later. We're not quite ready for that yet. So for the item base, we're going to make it a U object. So just the top level object class here, the parent class that everything in Unreal Engine is. It's a pure data class. The reason is because, as I said, there's no visual representation. There's nothing it needs to do in the game world. It just needs to travel around through our systems as the item data that gets initialized off of the data table. And so I'm going to call it item base. I'm going to go to my folders here. And I'm going to create a new folder, items. Make sure this is still set to public because what it'll do is it'll put the header in the public and the CPP in the private. That's what I want. I'm going to create it. Okay, so let's see. Did it pop up yet? Yeah. And okay, live coding is in the process of finishing. All right, so it's good to go. It's been added. Close this, and I'm gonna go ahead and close the editor since I'm done with it, and done with the launcher too. Okay, so the item class is relatively simple. It's essentially going to be a close copy of our item data struct, except it's going to have some functions in it and a few extra pieces of logic that will help as it starts getting made into actual inventory items. So to start with, we want to essentially make a copy of the item data structs. So the quickest way is to just come over here, get all of this, copy it, and put it right here in your generated body, under the generated body, I mean. And we can make all of this public. And now it's, let's see. All right, so it's mad about all these types, right? And so come up here, and we're going to include data, item data structs, and now that's all good. Let me minimize this. There, that's much better. Okay, so that's the core of it, except now we're going to add one thing. We're going to add the quantity. Because if you think about it, the data table just is the master database of like, okay, here's a potion, and this is all the different variables that describe it. But the data table doesn't care about the quantity. The quantity is something that only matters once the item is moved into an inventory or into the world. So if there's a stack of 3 and you go and interact with it and pick it up, that's the quantity that we care about. If you want to split a stack and drop 2, that's where quantity matters. And so that is tied to the ItemBase class. And it could go under numeric data. We could have put a quantity field in there, but because quantity is probably the number one aspect of the items that's changing all the time, I just felt like I wanted to leave it on the top level. So it's very, it's accessible, and it's very, apparent without having to dig down into a struct to get it. And so the quantity needs to be, let's see, it's uProperty, visible anywhere, it's ItemData. It doesn't need to be edited anywhere, just because you're not going to be editing these item bases directly. There's other mechanisms we have in place for that. We are going to make a setter for the quantity. You'll see that here in just a few. But yeah, for the most part, everything in here can just be visible anywhere. I did do this where you can set meta tags on uProperties, and for this one, since it's an integer, I used, you can see here, I've got it in the autocomplete, UI min and UI max. It says, for floats and integers, specifies the highest value the slider should represent. So for the minimum, it makes no sense to have a quantity of 0. That would mean the item, doesn't exist, or it should be deleted out of whatever inventory it's in. So the minimum should be a 1. The max, I'm just setting it to 100. The quantity per item is going to represent the stack. So if you have more than one, it's a stackable. And so I just, picked this number because it seems logical. I don't, I kind of like approach my inventory from a kind of realism aspect, and it just seems a little goofy to have a stack of anything that would even get close to that. So I just picked that number. Now, one thing that I do, and you'll see this going forward with all the classes I make, I like to keep my header files organized. And so I put these comment bars in here to keep everything like very nicely visually separated, rather than just having a giant list. And I actually do this for both the public and the protected or private sections. So in this case, I'm going to add a protected section and do the same thing. If you like this, then definitely, do the same thing, but if not, totally up to you. All right, so public functions, we have a constructor, obviously. Just making sure one wasn't already made up here. Oh yeah, duh. So ItemBase constructor. we are going to have a function that returns a pointer to an item, and it's called create item copy. I'll explain why this is important here in the CPP file. We're going to have a couple of getters that get some weight related info about the item, and so we can use force inline. So an inline function, if you're not familiar with that, in C++ there's a concept called inlining. What that does is anytime in the code, so after the preprocessor runs and the code is actually converted into the machine code, the compiler, the preprocessor, everything, after all that's done and you're in the machine code, an inline function copies the entire contents of the function to everywhere that it would be called. What that does is it makes your code a little bit bigger because you're copying that everywhere, but it significantly reduces the overhead of calling. So like in this case, the function is get item stack weight. Make it its const because it's not changing anything, it's only returning some values. So we're going to return our quantity times our numeric data weight. So weight being numeric data weight being the weight of 1, then when you do this, you get the full amount in the stack. So now back to what I was saying about inlining. Rather than making the function calls or have overhead associated with them, so rather than doing this everywhere that we want to get the item stack weight, making it inline would just copy this everywhere that this function is used. And so it's just a way for, it's just an optimization kind of thing. If you have little short small functions, that's when it's the best to use inlining. So like setters and getters, those are always good to use inline. So we're doing that again. We're going to get this time get item single weight, same kind of thing. This time we only get the weight itself. Another function is full item stack. This time we're going to say, does the quantity equal the max stack size? And if it does, obviously, that's going to return true because it means it's a full stack. The set quantity function is the next one. It takes in an integer, calling it new quantity. And then a use function. And this one's going to take in a character, the player character reference. And that's it. You can add other functions here as you move forward, or if you just want to experiment. This is all I'm going with for the time being. So these are already done. Set quantity we need to implement. Use is going to be actually empty for now because I don't have any kind of implementation for that yet. But set quantity, actually this one doesn't need to be a U property, but these, let's see, U function. I made these U functions, just category item. It doesn't hurt to make it a U function. Most of the time, at least when I'm working in C++ code, I really only designate things U function if they're going to be bound to a delegate. But I mean, it doesn't hurt anything. Go ahead and put it on all of them. All right. So that should be it for public functions. Now there's one thing we're going to add in the protected section. And actually it's just a single thing, so I'm going to go ahead and delete these. I just put them in there out of habit. When we're searching through the inventory for matching items, for if we want to drop something, if we want to merge a stack, or there's multiple different cases where we're going to need to search. If you overload the operator, the comparison operator, the double equals, you can make it to where you can so that the array that's used in Unreal Engine is called a T array. T array has some built-in functions that let you search the contents, and one of them is find by key. Find by key specifically says you can use this to search against a key for in the array contents, but those keys have to overload the double equal sign. This is definitely going to get revisited when we build the inventory component itself. But for right now, just know that doing this allows for a comparison when using those T-array functions. So because we already have a nice key that we can use to search for items, that is going to be our ID. So ID is an F name, which the name of that type is a little bit misleading. It's not a name as in like letters. It's a type of string. If you go read the documentation about it, it says, it doesn't say it here, but we could go to the documentation, but essentially what it says is it's good for stuff like an ID or like a short designator. So that's why I'm using F name. And so all this is going to do is when you go to compare two items, it's going to look and say, all right, does this ID match the other ID? So it's really useful. All right, so now let's implement these functions in the CPP file. So I'm going to use a nice feature here in Writer where I can just go ahead and create implementations all at once. So here's our constructor, create copy, set quantity, and use. Notice it's smart enough to ignore the force end lines, so that's really good. Yeah, okay. All right. So the constructor doesn't need anything for the moment because, again, we're going to be initializing these items from the data table with all that info. So this is fine to just leave this one blank. For the copy, the copy is, the copy is important because all this stuff in the inventory is going to be managed through pointers. And while I was debugging, I found that there was times where bringing a new item in, doing some operations on it, and then trying to merge it, say, with another item, it was essentially treating it as the same thing, and it was causing some bugs. And I found out that what I needed to do was essentially create a whole new pointer, a whole new object. Because managing it by pointer, I would bring one in, try to add it as a new item, but it was pointing to the same thing. Probably that bug might come up again at some point during this, but I'll just, in summary, it's just that you need an ability to create a brand new item copy from something when you're adding it to the inventory. And so this is going to be how we do that. So it's creating a new object, new ItemBase, and we're getting the static class. And so what that means is it's just going to be grabbing this static class, so the ItemBase static class, and using that as its template to create a new ItemBase. Then we just take our item copy and we set everything using this, meaning the one we're copying from. So set our quantity. quality, item quality. I thought I named that. For some reason, I thought I just put it quality. That's fine. It really doesn't matter. My reference that I'm referring to as I go along is slightly different, and sometimes I do something and I'm like, why did I do this a little bit different? It really doesn't matter. Another great thing about using the structs like we did is that we don't have to if we put every single thing in text data, numeric data, and etc. as a separate variable, we'd have to do type a bunch more lines, but because they're structs and we're copying these structs, we just copy it just like that. Statistics. And lastly, asset data. Now we can return item copy. And that's your copy function. Yep. And so member function can be made const. Writer will try to recommend you useful stuff pretty often. It's good to label things as const. For you as the programmer, it keeps it more organized for you mentally, because you're like, oh, okay, this is not supposed to change anything, right? That's what this const is representing here, that this function is not supposed to change variables. But it also does do a slight bit of optimization. I remember reading some research papers and stuff about this a while back for my day job, but I'll just say, I'm not going to try to speak authoritatively about it right this minute, but I know that when you have things as const, the compiler can handle them a little bit more efficiently. So maybe not for this function, but for like variables that don't need to change and stuff like that, it's a good practice to always mark it const if you can. Okay, so we're almost done with this class already. We just need to fill out the set quantity. So for quantity, we're only going to try to change it if it's not the same as our current quantity, right? Because why do we need to overwrite the variable? It doesn't do anything. So if we receive a new number that's not the same as our current quantity, we're going to set quantity using clamp. So that's in the fmath class. Clamp takes in three things. It takes in a variable, a minimum, and a maximum, and then it will return to you what it is. Either its current value, or if it's trying to go below min, or if it's trying to go above max, it'll return the max. So we're taking in new quantity, the minimum, 0, the maximum, I'm going to use what's called the ternary operator here. Ternary operator is just a way to say, okay, some really quick little pseudocode. If condition do one thing, else do another, okay? There's a really quick, nice way to sum this up in one line. And what that is you take your variable, so B is stackable, question mark, and now we put what to do if true, colon, what to do if false. So if it is true that it's stackable, we only want to allow the maximum to be the stack size. However, if it is not stackable, we only want it to be a maximum of 1. So again, this whole thing here, put a space there to keep it nicely formatted. This whole thing here is the same as this right here, where in this case our condition is this, and this. So I always use that because it's clean and I don't know, I just like it better. I like writing things a little more efficiently and saving lines if I can. And so it's really good for a case like this. So again, quantity is going to come in. We're going to look at it. It's going to be clamped to a minimum of 0, a max of stack size if it's stackable, otherwise a max of 1. Now, there's one variable that I forgot to add back here in the header file, and that is the owning inventory. So we don't have an inventory yet, and so we're not going to be able to properly use it. But it's a U property, and it's called, so the inventory component. So the class we're going to build is the U inventory component, and we're going to have an owning inventory. So go ahead and just comment this out for now, because we could forward declare it and stuff like that, but in the it won't matter because we can't use it in the CPP file. So I'm going to comment it out, and I'm going to add some more commented out stuff here that's a placeholder. And basically what that is what we want to do is we want to check, is there an owning inventory? And if there is, we can just kind of write it as pseudocode right now. And if you're not familiar with that term, it just means you're writing stuff almost in like plain English, and it's a placeholder, or it's a way to kind of describe some functionality that you're going to add later. So if we have a valid owning inventory, then what we're going to do is we're going to check if quantity is less than or equal to 0. We're going to, say owning inventory, remove item. Because as I mentioned earlier, it doesn't make sense to have a quantity of 0. If we are doing set quantity, it's going to be when we're merging a stack, and now one stack has completely merged to the other, or dropping something, like dropping an amount. Or using it, right? If we use it, we reduce the quantity. Anytime we change the quantity, we should be filtering it through this function. It will then be clamped to the proper amount, and then the inventory that it belongs to is going to look and say, is our quantity now 0? If it is, delete it. So that's essentially what this is going to be in the future. We're going to come back and finish this once we have the inventory. And that's it for the ItemBase class for now. Again, like I said, I haven't gone as far as actually creating items that do things in my game that I'm working on, and so I don't have an implementation here, but this could be something that you can expand. Feel free to experiment with it. It was pretty straightforward. We got some simple functions here that are going to be used later in the inventory. We got our set quantity, and we got our comparison. So yeah, I think we're ready to move on to the next step.